Hello, my name is Laura Kahn, and I'm a data scientist in the Accenture Federal Services Digital Studio. I'd also like to introduce my collaborator and colleague, Ian McCulloh, Accenture Federal's Chief Data Scientist. I'm excited to talk to you today about our case study entitled Simulating the Impact of Artificial Intelligence Innovations with a Modular Framework and Digital Twin. Over the next 10 minutes, I'm going to discuss our research abstract, introduction, research contributions, results, and conclusion. U.S. federal government agencies oversee a wide array of benefits or applications for citizen services that require an adjudicated decision. Federal Benefits Administration can be viewed from a systems engineering lens, approximating the complex interactions within the administration system. We model the Benefits Administration as a modular framework with many components that can be simulated, customized, and optimized. Artificial intelligence, or AI, is often touted as saving taxpayers millions of dollars without a mathematically rigorous way to prove the magnitude of these claims. Increasingly, federal government is embracing AI solutions across many agencies. In our research, we created digital twin discrete event simulation, including multiple components of a benefits system to approximate how much new AI solutions improve desired outcomes. But using simulation within a federal context is more than a research or consulting project. It's an opportunity to improve citizen services so that veterans may get health benefits to improve their well-being. Farmers may recover damages to their crops after a hurricane to feed more Americans, or dreamers may receive asylum decisions quicker to shape their family's destiny. How might we use simulation to improve these citizen services and others? Federal agencies are increasingly asked to deliver the same level of services as their commercial counterparts, faster and cheaper, and often with fewer resources and more constraints. Inefficiencies in processes can negatively impact citizens in need of time-sensitive and critical services. AI solutions within the federal government are consistently touted as bringing enormous amounts of value and improvement to government. Modeling Federal Benefits Administration as a collection of independent agents to execute behaviors allows agencies to customize and explore interactions and systems they manage with less risk. Now that we've introduced the problem, I'd also like to discuss prior research in this problem space. Discrete event simulation models systems that affect people's wait times to improve customer service, and these have been created in physical healthcare and other physical citizen service settings. In other research by Bonobo and Scala, human systems and business processes are modeled, each having a consortium of independent agents, and this has been shown to reduce inefficiencies. Now that I've talked a bit about the problem space in prior work, I'd like to discuss our two main research contributions. First, we created an adaptable macroscopic framework to model a federal benefits administration system. Next, we simulated a current state federal benefits system with a digital twin representation and discrete event simulation. In the federal benefits use case, we separate the benefits application system with an application intake process, since this may be where we introduce an AI solution, and we examine and quantify the trade-offs of introducing the AI solution. A modular macroscopic level framework with a benefits application system, application intake, decision maker network, and decision maker processes was created to approximate benefits administration operations. Any of the blocks within this framework could be defined with any number of agents, variables, and variations in processes represented as mathematical models in a simulation, depending on real-world needs and use cases. Benefits administration operations could be simulated and variability optimized using a general-purpose simulation software like Simio or other types of open-source simulation tools. In addition to developing the framework, we quantified the impact of introducing an AI solution during application intake in a benefits administration system. This helps better approximate and quantify impacts when changes such as this new AI solution are introduced to the system. Our second research contribution, the digital twin, contains simple and complex application sources arriving into the system with arrival rate R and application type probability DP. The applications are routed with some probability distribution D to an intake stage that either uses any number of human or AI resources. From there, the application goes to any number of steps with processing time T. The final step involves some type of comparison of the benefits application to the applicable rules and is also a function of the decision maker experience level. All applications receive a decision and exit the system as a sink in the discrete event simulation. In our digital twin, throughput and processing time efficiencies were measured and gained by the introduction of the AI application intake solution. The digital twin is adaptable to system changes as they occur and is a more rigorous tool for improving and measuring efficiencies within operations. Now let's double-click into the model assumptions a bit. There are two types of applications, 20% of which are simple and 80% are complex, with a random exponential distribution. The initial application type processing cost is $50 for simple and $100 for complex applications. Simple applications arrive every 8 minutes, while complex ones arrive every 4 minutes. Intake time without AI has a random triangular distribution between 60 to 95 minutes, while intake time with AI ranges from 50 to 70 minutes. A junior decision maker takes 30 to 32 minutes to process a simple application and 35 to 40 minutes to process a complex application. A senior decision maker takes 26 to 28 for a simple and 30 to 35 minutes for a complex application. Applications are equally distributed to each decision maker type. Application type probability, arrival rate, and intake time with and without AI were estimated after consulting with subject matter experts. The remaining variables are notional, but could be updated when working with a client based on their actual values. Furthermore, all distribution conditions were chosen at random, but are also adaptable and customizable. Following the model assumptions are the equations to calculate total time TT in minutes and total cost C in dollars of applications with varying levels of complexities, either simple or complex, using AI or not using AI intake, and with decision makers at different levels of experience, including junior and senior decision makers. We ran the simulation with these variables in under a minute, and we saw that the total time using AI is about 8% less and costs about 36% less than not using AI. Given the implementation costs of a new AI solution and weighing these with these increases in efficiencies, we decided to implement this AI solution. Our framework and digital twin can be used for modeling physical or virtual systems. In our case, we modeled predominantly virtual system. It has been adapted to account for the role of people and new AI technology within a benefits administration process and quantify how much new AI technology can impact a system. Customized variables could be introduced in any component of the framework, depending on the federal agency's context and desired outcomes. By perturbing the digital twin, federal agencies can understand and approximate how much changes to any parts of the benefits administration system affect the entire system, therefore improving the overall system and delivering better citizen services. Thanks for joining us today on our journey to simulate the impact of AI innovations within a federal benefits context. Feel free to reach out to myself, Laura Kahn, or my colleague, Ian McCulloh, if you'd like to discuss more about how we can shape the next generation of federal government simulation solutions. Thank you.